Yay. Okay, finally. All right. Oh, almost, guys, almost. All right. Hey. That took forever. Okay, so that's enough of this. Let's talk about graphs. Is everybody ready? Maybe. Hold on. Hold on one sec. Trying to make this smaller so I can. There we go. Okay. So, by the end of this lesson, you are going to be able to interpret a line graph, collect data, construct a line, and observe the differences in line graphs. Sounds like fun. Okay, so we want to make a graph. And with this graph, I want to think about the temperature yesterday. So what kinds of graphs would I make to show this? Write down in the chat box, guys. What kind of graph? Type it in the chat box. Yes. What type of graph? If you guys can read the screen there, it says I want to make a graph of the temperature throughout the day. So at like midnight, what was the temperature? Then at 1 o'clock and at 2 o'clock for every hour. What type of graph? All right, yeah, it's going to be a line graph. That's pretty straightforward because at different times it's different temperatures. All right, so let's see if I can draw this. I don't know if I can draw this. Ready? Maybe not. Pencil. It's not allowing me to draw. Now I can. Haha. Nice straight line. So what goes on my vertical axis? They're supposed to be straight lines. What goes over here on my vertical axis, the up and down? It's time versus temp. What goes where? Danny says time, or temp, I'm sorry. Devin temp, Caitlin temp, temp. It is right. Let's see if I can. This is the temperature. I'm pretty good. Right and sideways. There we go. What goes down here on my vertical axis? Time. I don't know about you guys, but drawing with my mouse is just not something I can do. Okay. So think about yesterday. Anybody up at midnight yesterday? So we're going to start here and we're going to call midnight 0. And oh, you were. All right, so what was the temperature outside? Let's say this is 6 or 50. That's a 5. And this is 100. So what was the temperature yesterday at midnight? Didn't check the news. It was cool. Say about 60. Sound good? All right. What about, let's say about 3 o'clock in the morning? Was it warmer or was it cooler than it was at midnight? We'll just go by that. Warmer or cooler? It was cooler than at midnight, about 46. Okay. So let's go down here. What about at 6 in the morning? Warmer or cooler? Then at 3 in the morning, warmer. So we're going to go back up here. Okay, what about at 9 in the morning? Warmer or cooler? Warmer still. I don't know, it didn't get really warm yesterday. And let's just go up to noon yesterday. Warmer or cooler than at 9? And warmer still. Okay, so this is a line graph. That's supposed to be a straight line. And as you go through the day, it gets warmer probably till about 2 in the afternoon. And then after that, it starts cooling off, hopefully, until the evening, which is nice and cool, right? So this is a line graph, and that's how you would gather the data for that line graph. The time down here is your independent variable. That's the thing that's changing. And then up here, your temperature, it depends on what time it is. So that's the dependent variable. All right, so that's how you give names to these things. So bar graph versus line graph. So what's the difference between a bar graph and a line graph? Anybody? Just what do you think it is? That's a good answer, Danny. Bars have bars, lines have lines. Very good, Dee. You're no nonsense about that. That's true. All right. Anybody else? Line graphs compare data. Yes. Over time, and bars compare different things together. That's true. Bar graphs will like group a whole, like from say an age group from 10 to 12, and like what their scores were on a specific test. They can compare data, but they compare data in a different way. All right, so those are good answers, but what we're going to work with today are line graphs. And a line graph is a graph that is used to show change over time. All right, what can time be measured in? So what are those measurements of time? Days, weeks, years, good. What else? Minutes, seconds, hours, months, good. That's right. All of those are measurements of time. Centuries, decades, good. So when do you use a line graph? Would we use a line graph in the following situations? To show how many people like pizza in a class, would you use a line graph? Good. All right. To show how much it rained each month this year. Yeah, because months and years deal with time. Good. To show how many people live in East Meadow, which is, I don't know where. No, because you wouldn't have something that changes with time. If you were just graphing how many people live like in Aurora, you would say, okay, there's, I don't know, 25,000 people that live in Aurora. What are you graphing really? The last one. Oh, you would, to show how much rain, you would use that. What about birthdays? What do you guys think? Would you use a line graph? No. Okay, but why? You're absolutely correct. You would not use a line graph to show birthdays, but why? Good answer, Danny. Good answer. Our birthdays deal with time, right? However, your birthday is constant. It never changes. Like Jumi's birthday is always whenever it is. I don't know, but it's always on that day. And where? Next month. Okay, it's in October. Danny's is always on June 23rd. Anybody else? Oh, my birthday's next month too. Yay. My son's is the 21st. Yes. Oh, January 1st. See, everybody's birthday is consistent and it never changes. So a line graph wouldn't show you anything. Okay, so well, I don't know about that, Danny. How do you make a line graph? Just draw a line, right? It's always a line, and the one thing that it really always has, this is something that's pretty important when you do draw graphs, it has a title. A line graph has two axes, right? What are those axes? X and Y. That's right. Horizontal axis is X, vertical axis is Y. All right, so just because it's fun to do, let's look at this. And what color is the Y-axis? Hopefully you can see the colors. Yes. What color is the X-axis? Yay. So you always have to have those two axes. And not always, but most of the time you will have those axes crossing each other. All right. Hi, Whitney, again. So when you're making a line graph, the x-axis is always horizontal, the y-axis is always vertical. The intersection of the two is always called the origin, right? And it's the 0 mark. It's the 0, 0 mark. Okay, and it's important to make sure that your intervals on the y-axis are always equal. And if they aren't, you should always draw that little sort of, not squiggly line, but like a Z type line to show that there's a break, if that makes sense. Let me see if I can draw it. So here's, if we start here at 0 and sort of a Z mark, and then up here, let's say we're going to start at 50. Okay, Monique. So this just tells you that there's some break, and then you can go up by tens or something. Does that make sense to everybody? Okay. So, intervals. This is what we mean by intervals. When you're setting up your line graph, we need to decide what intervals to use. And that's all representative of what your data is. So if you're graphing the temperature for a year, do we want to put 365 days on the graph and then 100 different temperatures? I don't think so. So you usually want to, like for 365, maybe go up by 10s, go up by 20s. You're going to have different intervals on the x-axis. And on the y-axis, you're not going to go up 1, 2, 3, 4, 5. Go up by 10s, 10, 20, 30, 40, up to 100, so that you have specific intervals. All right? So when you see a horizontal flat line, that means that there's no change, right? So a specific time period, straight line, velocity is the same, temperature is the same, everything's going to be the same. So It's important to read what information is on each axis. All right, and this is really, really important because when you're reading a graph, if it says, okay, what is the position of a car, you don't want to be reading velocity on the y-axis. And I'm just using that as an example, okay? All right, there must be a label on these axes. So whenever you do this, you have to make sure that things are labeled. Like a bar graph, we're going to look at the x first in order to plot our points. So rate per minute, so I don't know if any of you guys are in physics or if you had physics last year, what does rate per minute mean? What's another word for rate per minute? Really? How fast you're going? What's another word for how fast you go? Miles per hour, velocity. Good, what she said. Yes. Good, Dee. Yes, mile per hour. Okay. So, is this an acceptable graph? Look at the information. Yes, no? IDK? What is it? The lines are straight. Okay, is this an acceptable graph? Why not, Dee? It's got our x-axis is labeled, our y-axis is labeled, our whole graph has a title. Oh, it doesn't have the numbers. Okay, so it doesn't have like 5, 10, 15, 20. That's a good point. But other than that, yes. All right, you guys. Pretty, yeah, pretty savvy there. It's almost acceptable, right? It's got your y-axis labeled, your x-axis labeled. It's got a title for the graph. It's got a graph. The only thing it doesn't have are these points. Good. All right. So what information do you need to interpret the graph? The graph we just looked at does not have any numbers on the x and y axis, just like you guys said. So can we still draw conclusions about any questions about the graph? Yes or no? Let me go back. Could you still kind of decide what was going on with that graph? Whoa, went too far. Good, you could. You could say, okay, at this point it's moving forward. Then right here it's standing still. Again, moving forward. Stopped for some gas. Right here, it's moving backwards, and then it's moving forward again. So you can still get information about this graph, and it tells you how many times did it stop? Did that driver stop? I know you don't see it anymore, but yes, 2 times. All right. So we're going to look at these graphs. You guys have to look at them really quick because we only got 3 minutes. You see everything there? Try to memorize it. And I got a question for you. How much did the person spend, or which day did the person spend the most money? Do you guys remember? Do you want me to go back? I'll go back. What day did they spend the most money? Wednesday. How much did they spend? Okay. It's the highest point on the graph, and you can read how much they spent on the y-axis. Okay, how much money did they spend total on Monday and Thursday? It's going to take me a while to go back, so think about it. Think if you can remember. Whoops, whoops. That's craziness. Whoops. There we go. Monday and Thursday together. Yeah, about $9. Okay, they spent about $9 because you added the 5 on Monday and the 4 on Thursday. All right, real quick. Last one. I'll go back to it, but if you look at this, this is miles traveled and the days that they traveled that many miles during the week. So, how many days did this person travel 30 miles or less? Whoa, it's going crazy on me. Why does it do that? Okay, 30 miles or less. How many days? 5 days. Good. All right. Which day did the driver travel the least amount of miles? Sunday. And why might someone want to keep track of their miles for the week? Why? So they know how far they traveled. What else? I mean, I have down here to find out how much gas they need a week, but what are some other reasons? What if you had to travel for your job? Why would you want to keep track of how much how far you went? I will tell you. So you get reimbursed for gas money. Yes, so they can pay for gas. All right, we're not going to do this one or this one because we have run out of time. But it's the same kind of information. I know, you guys are sad. That's it. For those of you that are not caught up, please try to get caught up and please know that you can come and talk to me anytime.